Three more. Almost feel like one of those auctioneers, auction announcers. Like, I've got 8 students. Can I get 9 students? 9 students, 10 students, 10 students. How many students per class? All right, there we go. Here they come. And hey, that's everybody. Excellent. We are all here today. Wonderful. Double-sized class. Good morning, everyone. Hello, hello. Welcome back to Pre-Calculus, where we're preparing for the calculus. And as I've mentioned before, and it's worth repeating again and again, what the heck are we going to be doing calculus? Why are we doing all of this? How does this actually prepare us for calculus? And I think this week we have yet another wonderful example of things useful for calculus that are not themselves the actual calculus bits, right? It all comes down to algebra. In fact, there's a wonderful phrase that I don't know if it's gone beyond my circle, but at least within my circle of friends back in university, we would often say, okay, here you have the start of the problem, you apply the calculus theorem or the one calculus formula or whatever, and then in the middle you would say, and then algebra ensues, and then you get the answer, right? And that'd be a phrase we would often say, and algebra ensues, because the rest of the problem is like, well, it's trivial, it's not interesting anymore, you just do algebra to it, right? It's just manipulating the equations, and really, you can almost think of like pre-calculus as almost like an algebra 3, but we're not doing anything different than you've done from algebra 1. You're still adding the same thing to both sides of the equation, multiply both sides by the same thing, right? You're still basing it on those properties of equality that you learned in algebra 1. Except in algebra 2, we start throwing new types of functions at you. And then in pre-calculus, we're like, okay, now combine those types of functions with these types of trig, right? This is like the hard hitter of trigonometry right here. And that's where we're at today. Okay, we are in the middle of, well, actually, we're towards the end. Once we finish this week, this is like the last bit of massive trig formulas. Okay, and these are the product to sum formulas. And just like the other ones we've seen, the idea is somebody did all of the hard work for us, okay? Give them a round of applause for like, hey, good job, mathematicians of antiquity, for figuring this out. Because if you had to figure this out yourself, you'd be miserable, okay? They did the hard work. Like, here's the formulas. Anytime you decide, you know what? I've got this just gigantic thing, but if I could turn it into addition, it'd be so much easier. Or I think probably more commonly, if you could turn it into multiplication, it'd be so much easier. Oh, if I could just turn, because otherwise I've got all these parts that need to be added together. Okay? And sometimes that's the only way to go. All right? There is literally a process in calculus called integration by parts, in which you have to take the thing and turn it into separate pieces, and you turn what was a nice multiplication combination of functions and separate out into now this plus this plus this plus that. You're like, oh geez, if I could just combine those back together into one great big multiplication, a single looking function, one term, okay? Think back to polynomials, right? The more things you add on together, the more complicated it really gets because you have multiple terms to consider. So being able to swap, at least within trigonometry, from adding to multiplication and back again, makes it really simple. And these formulas let you switch between them with relative ease, okay? They're not that complicated. Let's take a look at some of these. Sum to product. So sine plus another sine, or sine minus sine, okay? It says sum to product, but remember differences, subtraction is just adding the negative, okay? It's really no different. Look at what we end up with here. We get 2 times sine of a combination of the angles times cosine. Okay, so it's now a sine times a cosine. And don't freak out about the fraction. Look, alpha plus beta divided by 2. We've seen that forever. That's literally the average of them, right? Right? Add two numbers together, divide by 2. This is subtract two numbers, divide by 2. I don't know. We don't have a special term for that. But you've done this to numbers all the time. Right? This is not written out all there. But step by step, as I'll walk you through a couple of examples, right? It's not too bad. Right? This is much simpler to deal, because remember, these will have values. Okay, these will be some number in degrees, or some 3 pi over 5 fraction of radians. Right? So at worst, you're going to have to subtract 2 fractions. Oh no. Right? Same with which direction am I going? Product to sum. Okay? These are even nicer. Okay, if you start with multiplying 2 of them, notice this one has the combination sine, cosine, or cosine, sine. Shouldn't really be any difference there, but whereas down here, we only have formulas for the combination of the two, or the matching sets, right? It's got to be sine and sine, 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 cosine and cosine, or cosine minus cosine, okay? No cross-mixing sine minus cosine. Then you'll have to use a different formula to try to transform one into the other, right? Then you might want to look back to the Pythagorean identities. Okay? But here, that's not too shabby, okay? If they're multiplied together, I get great big 1/2 times the whole thing. Not a big deal. And then it's just sine of add the 2 plus sine of subtract the 2, or, right, cosine the difference minus cosine of the sum, right? So there's a lot of pattern going on here. Again, if you can create a mnemonic to help you remember it, great. Otherwise, definitely have this on a reference sheet somewhere for quick lookup so that you don't mix up, okay, this one, 2 S's, so I get 2 subtracts, something like that to keep them, so you don't mix them up. But as I said, calculus will present you with a lot of scenarios where do a calculus thing to this, and you're like, it'd be so much easier if I could just calculate this and calculus that quite separately. The stage has curtains? Yes. Front and back. Excellent. Ladies and gentlemen, our stage is coming together. This is good news. This is good news. All right. Thank you, Ms. Partneck, for that update. Okay. So any questions at this point on what these things are and what to do with them? No? All right. So let me highlight possibly the biggest, most tempting, juiciest of common errors right here. And then we'll look at a couple examples together. Watch out for this. You will find this, and it'll say cosine of 75 degrees minus the cosine of 15 degrees. And your brain will tell you, I don't know the cosine of 75 degrees in the back of my head. I don't know the cosine of 15 degrees off the top of my head. Right? These are not numbers on my unit circle. Hey, but there's another part of your brain that is automatically doing math for you. Okay? You are at the point where your brain starts cramming things together, and it tries stuff secretly. Right? Maybe you don't ask it to, but it tries stuff. And it will notice 75 minus 15, that's 60 degrees. Okay, we could do that subtraction. That's easy. And then it'll tell the rest of your brain, the part that has the unit circle, be like, hey, 60 degrees is on the unit circle. And be like, by Jove, it is. I could do cosine of 60 degrees. And then it starts to look really tempting. Like, ooh, yeah, let's just make this cosine of 60 degrees. Oh, that's so easy. I can do that one. Okay, don't fall for it. Don't fall for it. Okay, this is not the same thing. This is why I absolutely hate it when people write stuff out like this. Whatever happened to our parentheses here? Okay, I don't know why. For some reason, the standard textbook typing, we've dropped the parentheses around the trig functions. And that's a bad habit to get into, because when you put the parentheses on there, now you suddenly realize, wait. Oh yeah, this is a function. This is an operation on 75. I've taken 75 and completely changed it. Then I've taken 15 and completely changed it. And then, only then, way after the fact, can I subtract those. Okay? We need to add into our please excuse my dear Aunt Sally order of operations. We need to add an F at the very beginning there, right? Perform the operations. That's why the parentheses help you consider that. Like, oh yeah, parentheses. Do to parentheses first, then subtract. This comes last. Okay? Same with this guy. Okay? Cosine of 7x times cosine of 3x is not cosine of 7x times 3x. Ooh, 7 times 3 is 21. Oh, wait. X times x? Oh, you tried to trick me. I'm too clever for you. That's x squared, 21x squared. I see what you did there. You're so tricksy, problem. Like, no, you fell for the trap, okay? Especially like on the SAT, they will love to offer this as a nice juicy multiple choice answer. Be like, ooh, click cosine of 21x. I said click, as if you're doing it electronically, right? Bubble in cosine of 21x squared, I dare you. Okay, no, don't fall for it, okay? Add more parentheses, all right? More parentheses, the better. Parentheses around that, and then say, oh, then that gives me this whole number. And then it's this whole thing times that whole thing, okay? Become accustomed to breaking things down in groups. Don't fall for it. Okay. Any questions at this point? No? Are we ready for some examples of this then? Okay. Good. I've got 2 super hot examples for you, one going in each direction. First, express cosine of stuff times sine of stuff as a sum or difference. I don't read the stuff first when I'm reading the problem. Just know, oh, it's a cosine operation, that's a sine operation. What do I have to do to it? Turn multiplication into sum or difference. Okay, got it. Now I'm going to look at the stuff. I'm going to look inside there and be like, is there anything that would help me here? Are these easy stuff or hard stuff? And then I notice, hey, this is 5x over 4, x over 4. They're both stuff over 4. That might be handy. That's good, right? That's a good sign to me, like, ooh, yes, excellent. They've already got a common denominator. That'll make combining things probably a little bit easier. I'm going to note that in the back of my head. Ooh, yes, good. Fraction combination, not an issue here. So let's look. A cosine times a sine. Let's do it that. Okay. Formulas. Cosine times a sine. Cosine times a sine. There it is. Product to sum, or in this case, product to a difference. Okay, that's the difference here. If you swapped it and put sine first and then it would be sine plus sine instead of sine minus sine. Could we convert from one to the other? Could we, multiplication is commutative that way. Could I rearrange it? Yeah, you could. Totally possible. But let's keep it in order. Cosine, sine. That way we can just read right off of here. 1/2 of sine of the sum of the two angles minus sine of the difference of the two. Okay, sum of the two, difference of the two, the sum minus the difference. 1/2 of the whole thing, sum minus the difference. I think I've got it. That's going to be equal to 1/2 of the whole thing. It's all sines. We said the sum minus the difference. So we'll take the sum of the two angles, 5x minus 4 plus x over 4, minus the difference. So sine again, except this time subtract the two angles. All right, there it is. There is the formula applied. Now we're just simplifying. Okay, what is 5x over 4 plus x over 4? 5/4 plus 1/4 is 6/4. Right, which we can reduce that fraction. They're both even, so 3x over 2. Okay. How about this guy? 5/4 minus 1/4 leaves us with 4/4. Oh, that reduces, it's just sine x. Okay, so far we have 1/2 of the sine of 3x over 2 minus sine of x. Is there anything else we can do to that? Are we fully simplified? I think we're there because it's still x, right? We didn't get rid of that variable. I don't know the actual angle. So I can't go and look up 3x over 2 on my unit circle and tell you what the sine is. All right? But as soon as I know what x is, I can plug that in. It's just a sine, and then just subtract another sine, right? Simple, straightforward from there if I know what x is. So that's our final answer. That's it. We're done. That's easy. All right? Questions there? All right, up next we have express cosine minus cosine as a product. Okay, we've got a minus. We're going to switch it to a product. Okay, so I'm looking for my sum to product formulas. So that's going to be, which ones came first? It was this one, then these guys. Sum to product. And it was cosine minus cosine. So let's find cosine minus cosine here. Again, it's the last one. Cosine minus cosine. Okay. So what does that turn into? That turns into everything multiplied here, and this is where parentheses would help, right? This is sine of all that inside, sine of that inside. -2 up front. Notice all of these get doubled somehow. 2, 2, 2. This one's -2. All right. -2 sine. And we have that average and that, I need a word for like the negative average. That's not quite it. But the difference divided by 2. This minus that one divided by 2. That's like, that difference? Is that the midpoint? No, midpoint would be average. Something like that, right? So the sum, half the sum and half the difference. Does it matter which order they go in? Not really, because it's sine times sine. So as long as I remember that I get one of each, I'm okay. -2, sine, half the sum, half the difference. Okay, let's try it. So this is equal to -2 times 2 sines and we need to take these two arguments, 8x and 2x, 8x plus 2x over 2, and 8x minus 2x over 2. There it is, filled in. That's our formula applied. Done. Now you get to the point, this is where you can say algebra ensues, right? We did the new thing, we did the tricky bit, we applied our latest knowledge, and now it's like, okay, now do the old stuff, simplify. Right? Okay, you could have turned to this, right, reduced that back in Algebra 1. Let's put the whole thing together. -2 sine of 8x plus 2x, 8, 9, 10. 10x divided by 2 leaves us with only 5x. Why am I writing it small up top? I divided by 2. You can write it down here. Times sine of 8x minus 2x. 8 minus 2 is 6. 6x divided by 2 is 3x. Is there anything else we can do to that? No, that's it, right? This is still a variable. So I don't know what the sine of 5x is because I don't know what x is. I don't know where this lands on my unit circle, so there's nothing more I can do to it. And this is still 2 times sine times a sine. That's as simple as it's going to get. That's our final answer. So what this really is subbing in numbers to the right equation and simplifying it. That's exactly it. Yeah, you've got it, Alex. As far as like first layer, now of course we can ask some slightly more complicated questions. Right? Let's take a look at some questions from the exercises there. Right? This is, look at what we have here. Now we can verify other identities using those. Be like, ooh, sine minus sine. So first convert this into a product. cosine minus cosine, convert that into a product. And then you'll have some product divided by some other product, right? Which means you can probably get some factors to reduce there, right? So as far as direct application of these formulas, yes. Figure out what is your arguments for each sine or cosine, what is your alpha and your beta, substitute and simplify, that's it, right? Match the formula, substitute, simplify. But they might ask you to also do other things, right? Here's a great other look at it, looking at the graph, okay? How could you, this is a graph of this. If you type this exactly as is into your calculator, you will get this picture. Assuming you set your window accordingly. How could you use a different equation, right? Suddenly looking at this, you're like, this is a sine plus a sine divided by more sine? But Mr. Apple, that's just one regular sine wave, isn't it? Like, yeah, it is, right? That's exactly it. This is the beauty. This is the visual right here. Ladies and gentlemen, you apply your sum to product, product to sum formulas, and you can turn this into sum a times sine of bx. Done. It's just a single sine wave. Or actually, this starts at 0. And we start at our highest at the 0. This is probably I guess it could be a cosine function. But you can always shift a cosine to make it look like a sine, right? They can always transform from one to the other. This is the beautiful thing about trig, okay? Is you can always turn one thing into a different trig thing. Okay. Final call for questions. One attempt. Show answers, power-ups, leaderboard, shuffle, shuffle, add memes. Sounds great. Okay, ladies and gentlemen, let's begin our quizzes. Let's see if I have the right. Oh, don't have the right one. There we go. Please go to joinmyquiz.com. Enter the game code 841429. We've got 12 questions. They are all as simple as my examples, if not simpler, so they should be fast, relatively speaking, right? Not any of the super long ones. And let's put these formulas to the test. Pop, 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 pop. It's like picking up items in Minecraft. I love that sound. Poppity pop, pop. All right. All right, give you another 20 seconds here. Let's get started. Oh gosh, the music is always way too loud. All right, do your best on your first attempt. Let's see what you can do off the bat. How well is this resonating with you? How much practice do we think we'll need throughout the rest of the week? As always, retake code will be posted at the end of classes today, thereabouts 2:30. You have your homework exercises posted to Google Classroom. When you are done with the quiz, go ahead and get started on those. All right, I think that'll do for the YouTube stream here, so we'll end that one.